I do work on the cheat sheet series. Why I think it's such a special project is because it's like 50 people working on it. Rather than build a book of 300 pages, we wrote a bunch of discrete one-page guides written by specific experts in that topic. So I'm one of the, Jeff and Dave started with the SQL injection cheat sheet and a few others. Now we have like 30 of them written by a large team of experts. And in my mind, that's the goal of OWASP, when we get people to collaborate of that nature. So I'm a board member for OWASP, I project manage some stuff, I write code, I write books, moving on. And just a couple notes about OWASP. OWASP, we're a 501c3 not-for-profit charitable organization. Our mission is to be altruistic, to give charity, to give knowledge back to the community, and this is why I do OWASP. You know, I'm a tech professional, write code a lot, and I want to do something to give back, and this is why OWASP means so much to me. Our core values, we're open, we're trying to push innovation, global, anyone's willing to participate, and we try to have integrity as an organization where we're an honest, truthful, vendor-agnostic global community. This means something to me. It's why I'm one of your board members of the foundation. I do my best to adhere to these principles as well. And open means rough consensus and running code, or published documentation, independent thinking, open information sharing, wide audience and participation among what are traditionally competitors, and we're all peers in this community. Again, these are words on paper, but they mean something to me. And when we adhere to these principles as a community, OWASP wins because of you. And this is what makes our foundation so precious to me and others who are a part of it. So let's talk about the OWASP Top 10. I have a concern with the OWASP Top 10 because a lot of people say, I base my AppSec program on the OWASP Top 10. And my thinking immediately is, what about number 11? Yeah, what about number 12? So I think you should read the OWASP Top 10 once and then never read it again. Move on to the Application Security Verification Standard and other standards within the OWASP Foundation. So this is another Top 10 presentation. My concern about a Top 10 is to write another Top 10, but I say read it once, discard it. It's meant for initial awareness, and then move on to more deep standards like the Application Security Verification Standard. As my own knowledge of AppSec progressed in the last couple of years, the OWASP Top 10 used to be one of my most prized documents, and I've shifted most of my work and my training where I all focus on the ASVS. That's like the OWASP Top 196. It's much more comprehensive, and those of you who care about security requirements, I'd like to see a shift in that direction. So I digress. So Top 10. This is, again, this presentation is meant for an initial awareness for developers and organizations who want to build secure applications. So number one, get parameterized queries dialed in. Step one, get SQL injection dialed in. Before any academic procedure, before threat modeling, before requirements, get SQL injection eliminated from your organization. And I've seen several very large organizations pull this off. And doing this complete pass through parameterized queries, we'll put Bobby up here, hey Bobby. Doing our first pass through fixing SQL injection gives us a chance to touch every code base. It gives us a chance to remediate by far the biggest vulnerability, risk, whatever you want to call it, that we have in AppSec today. You might not have databases around. This might not apply to you, and that's okay. This is a general document. And so I like to see people pass through all of their work, all of their applications, get SQL injection fully dialed in. It's a great first step as you approach application security maturity, and it's a single focus throughout the organization as well. A lot of people will say you can deal with this via input, you can deal with SQL injection via input validation. Is that a legal email address? Absolutely. RFC compliant email address, the HTML5 regular expression that's driven in the browsers, this will work as well. And how safe of input is this? It's brutal. You throw this into a query, it's going to lead to short-circuiting this query and updating the entire user table and changing every email address to blank because you put a legal, validated email address into a query with string concatenation. We know this. We solve it with query parameterization. It's the number one control. If you cannot get your hands around this, there's no hope for you. Unless you don't have a database, hey, there's no big deal. So we have query parameterization in PHP. We have it in .NET. We have it in Java, in HQL, and even in Perl. This is a mature control. And anyone know how this control works? How does query parameterization actually stop SQL injection from hitting your application? It's not as...
Doesn't it break apart the query?
Pardon me?
I just break it apart instead of doing the full screen.
That's piece of it. What's that?
Find it up front.
It defines it up front. You're now processing your queries when you code like this in 2 steps. The first step is your placeholder query. This is up here. Your placeholder query gets sent into the database and gets pre-compiled by the database, and it builds a query plan. Step 2 is the untrusted input that was bound into that query gets sent in, and they may contain attacks. But because the query plan is built, the query is pre-compiled, those attacks will not initiate. Those attacks won't actually work because, again, the plan of how that query will be processed is built and compiled already. This has been working for over a decade, over 15 years actually, and we need to code like this. There are a few rare cases where you can't parameterize a variable, like when it's a table name or column names. They shouldn't be untrusted though. Or when you have like a order by clause, sometimes a limit by clause, you can cast that to an integer. Those come up rarely. There are a few cases where you can't parameterize, but it doesn't matter. If you're beginning a program, and it's 2014, well, how many of you are beginning AppSec programs in 2014? I state with respect. Anyone? No one in the room, who here has been in AppSec for about a year now at your organization? How about 3 years? How about 5 years? So who is not doing AppSec yet? All right. Cheers. So this is something we've known for a while, and it still pops up, and we got to get it fixed. Let's move on. The second control I like to focus on is encoding and escaping. We want to encode data before use in a parser. This is going to cover things like cross-site scripting and LDAP injection and the whole family of injection vulnerabilities besides SQL injection. We don't solve SQL injection by escaping. We have better techniques to solve that. But when we move into the world of building a user interface, we have no choice, for the most part, to do escaping for traditional web applications. Here's an example of some cross-site scripting attacks that are stealing data or trying to steal a cookie and exfiltrate them. The amount of damage we can do with cross-site scripting is off the chart. We have to take this seriously. This comes up so often, I see managers getting numb to this. Oh, the cross-site scripting, let's not worry about it. But XSS is more than just XSS, because any cross-site scripting vulnerability can be used to undermine any cross-site request forgery defense. So when you allow JavaScript to inject your site, not only is it allowing the attacker to modify the page, it's also allowing the attacker to store CSRF attacks in your site. We saw that. We saw several worms across social media that did just that. So when a browser sees this character, it thinks of it as code, not display data. So if one of your users can put this character into their input that gets rendered to other users, this is going to be treated like code, and we'll use escaping functions to convert it to a display-only format. There's a variety of different libraries you can choose to do this. I'm a Java guy primarily, so I use the OWASP Java Encoder project. I use it instead of a SAPI because it's a single drop-in jar, it's built for performance, and we maintain just that library by itself. We have a lot better luck keeping it up to date and bug-free than a more monolithic library, more giant library like a SAPI, which has struggled in terms of keeping it up to date. So I stand by this. It's very fast and highly performant and low RAM usage. It's meant for cloud providers like a Google or SAP who's handling traffic that's kind of hard to even imagine sometimes. Well, the other benefit of this library is broken down. It's got the most granularity for any encoding library I've seen. Now we can take shortcuts and use just the parent and skip the children for these contexts. And let me take a step back. When you're building a user interface, one of the concepts I like to use academically is called perfect injection resistance, where when I build a user interface, it's a mix of variables and markup and JavaScript and other things. I am not going to assume anything about how those variables are populated upstream, and I'm going to protect every variable in the UI itself. So I'm protecting against JavaScript injection at the closest boundary as a software developer between the variables and where the parsers begin. So that's in my UI code when it comes to JavaScript injection. Encode everything, sanitize where necessary, and we can take shortcuts with this library and just use the underlying parent for each context, or we can build our own template engine that does this automatically. So this is one of my favorite libraries for XSS defense. It's written by Jeff Ikonowski, a PhD compiler theory student who went through the open source rendering engines to make these choices, not taking guesses, but doing the science to make sure those choices were correct. I'd love to see this port to other languages. Now there are encoding and escaping libraries in other languages. Ruby on Rails has a really decent encoder and mutual library. The Reform project has a little old school, but it has some good encoding for like Perl and JavaScript and other legacy. Asapi still has a decent encoder. I actually ripped out the PHP. There's a comma missing there. We'll survive that. Asapi has a good PHP encoder. There's not many encoding libraries in PHP that are reasonable today. And we have anti-XSS NuGet that came out recently that has a really robust output encoding functionality. Other things we see, we have LDAP encoding to stop LDAP injection in Asapi in the .NET XSS library. We have command injection encoding functions in Asapi. Be careful here. You should never let user data drive an OS command. We have XML encoding functions in the Java encoder, and we have some comparison study here from Border Security I found recently. So encoding and escaping is the primary defense to convert dangerous data to safe data without actually changing that data so much. We're just changing characters to an escaped context. So this is our main defensive layer against injection. Next, input validation. This is a debatable topic in my mind because I can build a really strong, secure application and skip all validation. The more important defense is not when you first get that input, it's when you use it in your system. So, for example, if you have an article, for a news article, and you're adding comments, what characters can I allow in those comments as a developer? Letters, uppercase, lowercase, spaces, and punctuation? Guess what? That's all I need to cause harm as an attacker. How about, make it even worse? You want to support internationalization? Does anyone here in the room do really strict language-specific input validation for the sake of security and internationalization? The answer is probably no. A lot of us punt and use a printable character regular expression to handle internationalization. So input validation tends to get weaker over time. It's not a layer that I think you should depend upon. Now there's some special cases pop up. When you have HTML input into your web application from something like TinyMCE, that's a WYSIWYG editor in the browser as a text area, and when you submit this text area, it submits as a chunk of HTML. It's meant for rich markup. We see this in admin consoles a lot. So how do you fix that problem? You want to use one of the tools I go to is the OWASP HTML sanitizer project. There's another Java project. It's written by Mike Samuel from Google's Mike Samuel from Google's AppSec engineering team. Look at the trend here of libraries I want to endorse. These are not ones written by the security community. They're really written by the developer community with help from the security community. I think controls that I've seen built by security professionals tend to be much weaker with respect than those built by real developers. So I want the development community to really embrace this, but they need help from us, the security community, to do it correctly. And here's some examples of how to build policies in this. The top policy is allowing different types of images. The bottom policy is allowing different kind of tags. Unlike anti-SAMI, it's allowing programmatic configuration of what you're going to allow through when you're accepting untrusted HTML. And I actually use this defense not just on input, but I use it in the user interface itself. Remember, I don't want to assume how variables are populated in the user interface. I want to protect all of them, so when things change upstream, my UI is still locked down. So encode and validate in the UI for all input. It tends to be a good future-proofing way to write code. And there's HTML sanitizers in every language, just about. We have Mike Samuel, again, in the JavaScript world from his Kappa project. Python's got Bleach, PHP, I want to recommend HTML. We have .NET, again, their recent NuGet. It does have a get safe HTML fragment function, which is broken, and to their own admission as well. So we have the HTML sanitizer from Mike Samuel was forked to C#. It's one of the better ones for .NET right now. We also have Ruby on Rails for before the 4.0 world. We have the Lufa project, and from 4 and above we have HTML. And in Java, I tend to use Mike Samuel's work. Another kind of specialized validation that pops up is dealing with file upload. This is an incredibly difficult topic. We're working on a cheat sheet to help you here, but just getting started. Antivirus, validate file name, validate file size. Make sure that you're using your own trusted file name to put it on disk, not the name from the user. Beware special files. And actually verify the contents of that file. If it was like an image, I recommend things like image rewriting, like load that image into ImageMagick and then save it out. If it's not a real image, that will break, that process will break. So this is, in my mind, this is one of the most difficult areas of application security, getting really rich file upload technology to work well. So next, let's implement appropriate access controls. So I think that one of the greatest failings of us as a security community is not providing developers with good access control layers. How do most frameworks deal with access control today? Pardon? Role-based. So what do I think of role-based? I think when I see roles hard-coded into applications, I flag it as a vulnerability these days, as at least a design weakness at the very least today. Because these hard-coded role checks, you're mixing two things. You're mixing the enforcement point, which is where in code you check for access control rules, and you're mixing the rule system, which is going to check if that rule is actually linked to the user in some way. In formal standards like ABAC, that's the attribute-based access control standard from NIST, they're encouraging this to move away from this kind of behavior. So of all the things we can talk about in access control, the main thing I like to talk about again is the enforcement point. Because if we get the enforcement point correct, everything else that we really need for good access control tends to fall into place. We're almost forced to make that fall into place. This is traditional access control. We tend to see this code written throughout thousands and sometimes tens of thousands of lines of code scattered all throughout your application. Let's have a moment of security confessions here. This is a chance for healing and redemption. How many of you are writing or working on an application that has these kind of checks scattered all throughout the code base? Only one or two, three, there we go, a few more. Who else? Come on, redemption, healing, yeah, thank you. And how's that working for you? How's that working out for you?
It's legacy stuff.
It's legacy.
Love that word, legacy.
See, the problem with this is it becomes difficult to maintain over time. It becomes difficult to prove the security aspects of your software, whether it's through manual or static type analysis or dynamic analysis for that matter. And when you want to change the code, when you want to change the permission set, you want to change the code. And even worse, anybody of you support multi-tenancy in your application? Does anyone here have to support different customers who demand different access control rules? And how's that working for you in that world? I actually saw code recently where every access control check was like 3 pages of code. If the customer is 1, check these roles. If the customer is 2, check these roles. If the you get where I'm going with this? And this becomes completely untenable. It's unmanageable and fragile over time. So I want us to code enforcement points to permissions like we see in Shiro and some emerging frameworks. So now I'm saying if the user is permitted to wield a lightsaber, I don't care if they're a Jedi or a Sith or a cyborg, whatever role class they are, in my enforcement point, I'm just going to check what are they doing. Behind the is permitted function, I'll look up in a database who the user is, what entitlements they have, what feature they're trying to execute, and what that allows, and so on. So I push that to a data-centric system that lets me feed any arbitrary attribute into my access control system, like time or geolocation, downstream, without having to modify thousands of lines of code. Also, I get multi-tenancy in a very easy way. I look up the user, look up their customer, look up that table, and boom, without having to change all this code, it's data-driven. And I like to start my applications this way because what's simple today is super complex tomorrow. That's just the way software works. I can even do data-specific checks with permission-based checking here. We have the request get Winnebago ID from the movie Spaceballs, that's right. I'm trying to drive Winnebago of a certain number, and even with that data-specific check, it's very easy for me to genericize this and have one enforcement point while supporting a large customer base of different rules and controls needed here. Next, establish authentication and identity controls. This is a huge, giant topic. I like to talk about password storage while I have this little bit of time. It's something that a lot of us get wrong to this day. I very rarely see this done correctly in code, and a lot of misinformation from our community. Just something out there. So these days, we want to avoid hashing for password storage. We want to avoid symmetric encryption for password storage. We want to avoid asymmetric encryption for password storage. The only thing we should be using is a KDF, standby. So number one, do not limit the length or type of characters from a user password. You ever go to a bank and have the bank tell you, please only use 8-character passwords and don't use any special characters? You ever see the error message in the bank? Yeah. Here's what the error message really should say. It should say, look, we have a lot of bonuses to give to our banking executives. We really can't afford to upgrade our system so we can support large passwords. We may do it in a year or two after we get the bonuses out. Something like that is what it really should say. And there's no excuse for this. It's really bad security. So we had an era about 3 years ago where like top 5 tier banks had no multi-factor in the US and only allowed 8-digit passwords. This is insane. And so we're getting beyond this level. So be careful. It can't be too big. Django, September 2013, they were using PBK-DF2, and this standard that's good for password storage. It's slow, and they were actually denied as serviceable very easily because they allowed unlimited size passwords. So they limited down to about 4,000 bytes, which fixed the problem. So not too big, but at least have some kind of limits. So number 2, use a cryptographically strong, credential-specific salt. What's the purpose of a salt in cryptography? It's the same thing as an ID. When you and I have the same password machine, what's the ciphertext going to look like if the protection algorithm is the same? If our password's the same, our ciphertext will look the same. That makes attacking a large database of passwords very easy, or at least easier. So what we want to do is when you create your account and your password, try and reveal it to everyone, you'll get to change it quickly. Fluffy Bunny 1, am I right? Like mine, so we have the same password. Who's heard me tell that joke like 10 times? Sorry, yeah. So we have the same password. Our ciphertext will look the same when we store it. So we had a different random salt to each of our passwords. When you register, you get a random salt. When I register, I get a random salt. We attach that to the password and then store it, and that deduplicates our ciphertext, even when the plain text is the same. In the world of AES, they call this an initialization vector. It accomplishes the same goal. Number 3, this is what you should be using. You should be using PBK-DF2 as the weakest good choice, bcrypt as the next acceptable choice, and scrypt when you want to do hardware accelerated attack resistance as well. This is a difficult topic, and the goal of picking these algorithms, what gives you the security is the work factor, is what slows it down. For about $5,000, you can buy hardware that does about 150 billion hashes per second. And by using one of these algorithms with a decent work factor, we'll slow it down to limit how many attempts per second the attacker can do offline. And so, again, I think bcrypt is probably the best call for PHP. For Java, PBK-DF2 is native to the language. For .NET is a really good bcrypt official library. So I would use bcrypt when I can. PBK-DF2 when I need enterprise type support. Also, for very specialized situations only, ultra high performance, isolation of the crypto, you can use an HMAC in certain specialized situations when you have a huge number of users logging in concurrently. And by the way, let's have a moment of security confessions, a chance for healing and redemption. Right? How many of you are part of a billion or more company, and you have an enterprise security system that doesn't have multi-factor, where this password would let me into one of these, where this password would be an acceptable password in your enterprise? How? So if I see some nods, I see a couple slow handshake. How? Let me ask you this. How good of a password is this to protect your multi-billion-dollar enterprise? Against a standard enterprise password policy of uppercase, lowercase, number, and alphanumeric, this would be my first test. We do a vertical attack. Horizontal, we do a vertical attack, one password against each user. How many will I pop in your system? The answer should be no. You look in the JavaScript of Twitter, they actually have a password ban list on the client that I think is a really good idea. So traditional password policy is awful. You really want to stop. Attackers today ban commonly used passwords, ban several thousand or more, and make that a moving target. It's a much better policy than what we're used to today. And this whole conversation is bunk. The era of the password as a sole authentication factor is so dead. made a bet with a lot of other security folks that in 10 years passwords will be dead. About 5 years into that bet, I think I'm going to win that bet. I think the era of the password is finally being ripped out of major systems. We see Twitter moving to a phone SMS-only system, debatable. We see Google releasing a USB system. I think we're at the dawn of mass consumer usage of non-password-only authentication mechanisms. And so look, here's no way of saying it. But I'm protecting my 30th level wizard and fighter with Multifactor at Blizzard like 8 years ago. If I'm going to protect my online video game character with Multifactor, you probably should protect your multi-billion-dollar enterprise from it as well. And so, and the last thing, Multifactor solves the problems of today? No way. It doesn't stop phishing, doesn't stop malware in your browser. It stops problems like brute force from 10 years ago. This is why Europe did this 10 years ago with their banking system. When we look at fraud between Germany and the US, it's like 1,000 to 1 in our banking system. The German laws in terms of online banking, are very strict, very, very strict, the German way, and it works. And we look at our own FFIEC, the regulations for online banking are very lax, so we need to move in a more regulated environment for online banking, I dare say. Those of you who are free marketers, I apologize, it's my opinion. Moving on. So here we have a forgot password workflow. A lot of us use password reset links, or you email the password. Look at how a bank does forgot password. It's a multi-factor workflow. On the topic of identity and authentication, re-authentication. Here we have Facebook, Twitter, Amazon, and Meetup all demanding that I provide my password just to change my email address. That's a good idea. We don't use re-authentication enough. We should use that change password, login, re-authentication, session timeout, and in front of sensitive features. In fact, when you use an online bank out of the US, every single transaction you make requires some form of authentication. We need to move in that direction in the US, I dare say as well. Authentication and identity is a giant topic. To get started, I recommend these 4 cheat sheets. Authentication, password storage, forgot password, and session management cheat sheet. We also have the ASVS requirements. Now we're getting into real breakdown of requirements. ASVS 2, 3 or 4 pages of authentication, we got 2 pages of session management, and this is how I roll when it comes to identity. Again, ASVS, the Application Security Verification Standard. This is a great place to start when driving software security requirements in your organization. Let's talk about data protection and privacy next, while we're let the fire hose continue. So, what benefits does HTTPS provide? This is encryption in transit. You get the confidentiality, the spy can't see your data. You get the integrity. The spy can't modify your data. You get the authenticity. The server you're visiting is the right one by the authority vested in the certificate authority system. Which is a complete joke. Yeah, the whole CA system is bunk. I'm sorry. And it's not going away anytime soon. But let's talk about it. Let's talk about what you as a developer, what you as an application administrator can do to make SSL dialed in today. Because you can. The pieces are in place now. Let's look at them. We have certificate pinning, strict transport security, new ephemeral forward secrecy ciphers, and other initiatives. Let's look at them. Strict transport security, go back to 2009 with me for a moment, where we have Moxie Marlinspike on releasing SSL Strip at Black Hat, which basically lets you strip out the HTTPS portion of any connection and still show it as HTTPS to the user, while still dropping it down to HTTP. This blew away the SSL community, yet another stake in what we thought was a coffin. But this came out to counter it. This is from Andy Steingrubel at PayPal at the time, strict transport security. If you make an initial connection to my server over SSL, then I can respond to that with this simple header, strict transport security, max age is a certain number of seconds, include subdomains. Hat tip to Hansen, you gotta use include subdomains for privacy. This will force the browser to make only SSL connections, HTTPS connections, from that point on. You want to really talk security? Let me go back. You really want to talk about real hardcore transport security now? Say yes. Yeah. You can actually go into the Chromium project and hard code your application, your domain, into Chromium, which is picked up by Chrome and Firefox and Aviator and other browsers, And now, you can actually have the first hit to that server be forced to be SSL. Now normally, you make a request to my server over HTTP, I'll respond and tell you to redirect, then you'll redirect to SSL. It's too late. If I'm on the network, the initial connection's HTTP, I got you, it's game over. So that redirect isn't the best way to roll. This will allow even the initial request leaving the browser, Chrome and Firefox today, to flip it to SSL if an HTTP request is made. So now that first hit to HTTP goes away. Only about, besides Google and Twitter, only about 1,000 domains are on the preload list. If you're really trying to get deep SSL security, this is the way I would roll. Hard code your domain in the browser. So what about CAs, certificate authorities? We have cases like TurkTrust, the French cybersecurity agency, and TrustWave abusing their private key as a certificate authority in some way. I'm not trying to point the finger. Yes, I have pointed the finger, so I'm pointing the finger. Sorry about that. But and to TrustWave's credit, they're like, look, it's not just us who did this, and we'll stop doing it. Every one of our peers in the CA is abusing their private cert in some way. If you give me a private cert to a CA, I'll create a fake certificate for your domain, sign it with my CA certificate, and hand it off to you, and it's a fraudulent but properly signed certificate, which is a big problem. So we have pinning. So, and if you look at the case, go look up the TurkTrust and French cybersecurity agency stories to see what happened when they tried to do this. They were basically making fraudulent certificates to, I think, spy on their populace in some way, but Google had implemented certificate pinning. They took versions of Gmail and other Google services, and they hard-coded it in the browser. So when people were going to Gmail in Turkey, and they were being given fraudulent Gmail certificates that were properly signed by TurkTrust, Google Chrome alerted them that their privacy had gone away and that they were being eavesdropped on. And this became a very big deal in the SSL community because when TurkTrust did it, it was the first time Google admitted that they were doing pinning, and it kind of went away. When the French cybersecurity agency did it a year later in December of 2012, they got knocked out of every browser. Chrome got rid of them right away. Microsoft, Opera, and Firefox, Mozilla, they followed suit and tossed the entire French government out of the browser as a CA. So this is a big deal back in 2012, 2013. And certificate pinning is what we have to detect when we get those fraudulent certificates. We can hard code them in mobile apps pretty easy. We can hard code them into Chrome on Android pretty easy. We have experimental headers in Chrome and Firefox today to let you do pinning to a response header. And when you're violating, you'll see something like this. Your connection is not private. Attackers may be able to steal info from you. So that's kind of warning that people got when they got man in the middle. The other thing we have that's really neat is perfect word secrecy, ephemeral cipher suites. Up until recently, if I stole the private key to your SSL server, I can decrypt any traffic over SSL for the history of that server. Here, now we have ephemeral cipher suites with a private key, and the keys made for symmetric encryption in SSL itself have nothing to do with each other. So if I crack your key and reveal some plain text on SSL, I get a little bit of data, and I have to start over for every chunk of data I'm trying to decrypt. It really makes advanced adversaries who are using massive hardware to crack SSL and shut off their capabilities in significant ways. And after Snowden, I'm not trying to get political, but after Snowden, all the different servers and browsers rushed to support this, and they're now, in just 6 months, these ephemeral cipher suites, a very big deal when it comes to privacy and good SSL connection, these are now widely supported. And we see on the top, so if you want to use ephemeral cipher suites, it's usually just modest configuration of your server and you're good to go. The browsers are all in place now, overall. There's going to be a talk here, I think we just had one last hour. There was a talk that showed that it's not that you're using or not using ephemeral cipher suites. There's like a maturity curve of how your organization is doing. So I would definitely get a recording of that talk if you haven't seen it already to help measure how well you're doing this. It's the only, we need this to do SSL correctly. And so how about cryptographic storage? We're usually told to use AES. We want to avoid ECP mode. We want to probably use GCM mode, which isn't widely supported, getting better. So we're probably stuck in CVC for wide enterprise support. And we want to have a unique IV per message for deduplication. We want to get our padding correct. We want to do our key storage management such correct. And that only gives us confidentiality. So if you're using CVC, you have to HMAC your ciphertext for integrity and derive your keys from the same master key with proper labeling. Know if you've already been master key, and good, we're legal, luck with that. Yeah, you're some real the best people in the world get this stuff wrong. So don't write crypto. Don't ever talk to a key in your application code. You should be using a separate service with something like Keysar. In my mind, Google Keysar is the only good applied cryptographic library. All the mess of padding and what choices to make, and how to do key rotation and key families, all the good parts of a real rigorous crypto system, it's handled for you within this library. It's reasonably well maintained, and it's supported by Java, Python, and C++ in an interchangeable way. And again, never do this in my application. It's always about isolation. That's kind of the real hallmark of key management, is to isolate that from the rest of your application. Push it to a separate service, reduces the problem to just authentication and access control from that point on. We also have intrusion. How am I doing on time? How am I on time? We have 10 minutes? Let's keep going. A little break for a second. Little break. What's that? Any questions so far? All right, let's go into intrusion detection now. Error handling, logging, and intrusion detection. I'm going to skip the error handling and logging part. That is important, but let's talk about intrusion detection for a moment. When you have a web application, complicated web service, some kind of custom enterprise software or whatnot, the idea of putting a product in front of your app to give you good intrusion detection, I think, is a failure. I don't think that's the way to roll. We really need to embed this protection in the application itself as much as possible. So things like, if I see someone trying to modify an immutable field, like a checkbox. When you have a checkbox in your form, it's either checked or unchecked. I either get the value or an empty string. And if I get anything else, someone's using an intercepting proxy to mess with my software. I can lock that account right away. So this is an example of intrusion detection prevention that you embed in your software itself. We also have, we look at things like latent SQL injection, abuse of a multi-step workflow, and things like custom business logic, like I might put the price as a hidden variable in a shopping cart. Who here is a pro pen tester? Who here does pen testing for a living? All right, let me ask you a question. You go to a shopping cart, right? You see an item pop up, you go view source, and you see item ID, quantity, and price, and a submit button. You can't help yourself. What are you going to do? Say, -1. You're gonna mess with the price right away. And so what I like to do is I put the price as a hidden variable into the shopping cart, but I never use it. I actually get the ID, look up the price, and make sure that, what's your name?
Mission.
I make sure that he does not modify the price. It's just a honey trap, a honey token. To see if, and it's something that any hacker, they can't help themselves. Oh, a price, I gotta reduce it, right? A lot of the research I've seen on intrusion detection, my heroes are Nick Galbraith and Zane Lackey. Zane is actually here at the conference if you want to talk to him. I like the work that they're doing in this area. It's some of the most mature. I'm also a big fan of John Bell and Coates and the OWASP App Sensor team, who have a pretty rigorous Java project to allow you to add sensor points deep in code for the sake of intrusion detection. Again, in code, much better than a product which doesn't have a deep understanding of how your software works. We also, I'm not going to go deep into this, but there are so many good controls built into frameworks these days. Ruby on Rails, Spring, Struts, they're not perfect, but they're there. Like, for example, if I use the default Struts UI components or the default Ruby Struts UI components, they tend to escape properly by default. So, a good place, one of your initial steps is truly to have mastery of your framework and understand the built-in security characteristics and to use them properly when you can. It's also just as important to know when not to use them. If you have like really rigorous access control requirements, like we talked about earlier, then using your framework's built-in access control is usually a really bad idea. So it's not just important to know when to use your security characteristics in the framework, it's just as important to know when not to. So coming to the end here, let's talk about security requirements. How many of you here are developers in the room, man? Developers, good. How many of you have been given clear requirements for your job in the last year? You're kidding me. Okay, how many of you have ever gotten requirements in the scope of your entire career? All right, good number. How many of you have ever gotten prescriptive security requirements as part of your requirement doc? 1, 2, 3, a few. How detailed was it, may I ask?
Almost like a top 10.
So what about number 11? Get the 10 working, and 11 doesn't matter anymore, right? Who else has gotten good security requirements as part of their software development work? What do you think? Like, how detailed?
Pretty detailed.
Well, give me an example of what level of granularity, if I may.
You'll implement checkpoints for input validation.
Oh, heck yeah. So what it really was, technically prescriptive of how to build security in.
We also wrote most of their requirements that we got back, so.
So here's my question. If you're not given clear security requirements, then what are you going to build? You're usually not going to build to that. We're trained to build to requirements. And so if you want it, and very often a company is demanding security of developers without telling them what that means. And we need to tell developers what that means if we have any chance or any hope of really building secure software. Is that fair?
Yeah.
So I'm a big fan of security-centric requirements. We have functional requirements, that's QA testable. We have non-functional requirements, things like password crypto behind the scenes that might be more difficult to test. And one of the places to start with security requirements in my world is, again, OWASP ASVS. This is the Application Security Verification Standard. It's a list of 190 or so verification requirements that can very easily be transferred or converted into developer building requirements to at least describe what our vision is of secure software. I wouldn't just throw ASVS at my developers. I would go through it, vet which ones matter for your organization and software, and convert those into my own documentation. So we're really not just saying, please build me secure software, and the requirement I'll give you is build secure software, and if you don't build it, I'm going to blame it all on you. We can't do that anymore. We have to have clear documentation around what security means. And again, if you're like a two-man startup shop, that might be a pipe dream. But if you're an enterprise software shop, this is how you have to roll. And even if you're, how about this? If you're a developer and you're not part of a mature software organization, at the very least, here's a resource for you to start with around building secure software. Last but not least, secure architecture and design. Some people call this threat modeling. I think it's more of a building kind of vision where I want to understand different tiers of trust. I want to understand what my business, technical, and security stakeholders want. I want to understand my own culture and software development life cycle so I can make modifications there in a more gentle fashion. Some people say you must, with an iron fist, show up and change the SDLC and make everyone change how they write software. If you do that, you will lose developers. It is really hard to hire good developers. It's a very competitive market out there. So I have better luck in terms of retention and actually getting what I want of taking what the developers are doing today and trying to make small changes, embracing their current culture. This requires a high EQ. This requires like good interpersonal skills and the desire to understand first before you make decisions. It's not our nature in this industry. So it's a difficult thing to do well. And I find that lightweight processes are more successful than expensive, heavyweight, heavy documentation processes like agile threat modeling. And so one other interesting thing that pops up in the area of architecture is trusting input. This is from Jim Bird, who runs a company that builds software for stock exchanges around the world. And man, when you're in this kind of software, fractional second delays mean billions of dollars. So they have a whole different vision of what trust is and what tiering is, and they have no choice but to trust certain data at certain layers of their architecture, because again, a 10 MS delay is going to mean billions of dollars in that situation. So we do have specialized situations. My vision is treat all input always as untrusted and use security and build every component to be self-defending. That's ideal. but certain situations come up where that's not practical or even possible. And so, yeah. So I appreciate you listening. I hope it was useful to you in some way. Any questions before we finish up? Yes, sir.
With the increasing use of like NoSQL databases, do you see injection into those systems, and are there any mitigations around these like parameterized queries have been around forever, but
Sure.
with NoSQL,
So
what kind of tools are that?
the first generation of NoSQL databases, people would programmatically query into those with function calls.
Yeah.
Like get me data of this type, and then sort by this. It's all function based.
Some will have SQL-like language.
And then some, which is all, now have an OQL-like variant language to do advanced queries, because using programmatic function calls to query into a very complex data set for advanced search capability is non-tenable. You end up having to do OQL. And what's OQL? OQL is an object query language that's often a mix of your queries and untrusted data. So you can have object query injection against a NoSQL database, because they now all support SQL-like variants. And so in those cases, you just like when you're using HQL, Hibernate query language in the world of Java and .NET, you have to parameterize every variable. So it does pop up, even in the NoSQL world, on occasion, and more frequently as we see these databases being used in advanced reporting kind of infrastructures. There's my, it's less of a problem, but still there. Any other questions?
You have to build your own layer.
I hope this was a good use of your time. I appreciate you coming, and go forth and write secure code if it is possible. Thank you very much.